Hello, welcome back to Hidden Gems. My name is Arden Thomas. I'm the Cincom Smalltalk product manager. Hidden Gems is where we show you capabilities of the product that you may not be aware of, but we think you will benefit from. If you have any questions, comments, suggestions, please send those to athomas@cincom.com. That's myself, Arden Thomas. So today's screencast is about performance profiling. Where does the time go? If you have code that executes slower than you think it should, and you've wondered what specifically is slowing it down, where's the bottleneck, you'll find these profiling tools of great value. And research has shown over decades, often where you think it's running slow may in fact not be the case. It's a difficult thing to guess at, which is why these tools are so valuable. So if you're a longtime Cincom Smalltalker, you've probably used these. If you have not, I definitely recommend taking a look at what I am about to show you. So in this screencast, we'll build a simple word counting example, and we'll deliberately make it slow. Then I'll show you how to time the execution of that code, how to load the profiling tools, how to profile it, and then we'll try to improve the code. And then we'll talk a little bit about improving performance in general. So let's go to our example. Here's an example. I took a random file off the internet, created a text file. I create my file stream, the text file as file name read stream. I create lines as an ordered collection. Then I say file stream at end. We'll get a line, which is file stream up to a carriage return, and add each line 2 lines. We'll get rid of the lines that are empty. Here was a little problem I ran into with tabs in the line, so I replaced all the tabs with a space. And then I wanted a lot of lines, so I doubled the number of lines. Lines concatenated with lines 7 times. Then I created words as an ordered collection, went through each line, got each word by saying to the line, tokens based on space, reject any ones that are empty, and add all those to words. Then I rejected any words that the first character was a number, so it wasn't alphabetic. And then I had words. So I do that. If I look at the words, let's take a look at that. Here I've got lots of words, thousands of words. How many exactly? I've got, wow, almost 200,000 words. Big number of words. But how many are unique? If I say to those words as set, which silently discards duplicates and sort them, let's take a look at that. So I have 754 unique words. But how many times does each one occur? That's what we're going to do here, and this is going to be a bit slow. For each unique word, we're going to go through the words and select all the matches and get the size. Then we're going to create an association with the word and the number of times it's occurred. So if I do this, I will get, let's go ahead and do it and inspect. It's going to take a few seconds to run because we created a lot of lines. And we see A has occurred 256 times, reporting 128. Let's go through. There's some that are many more. Here are, say is 256, and so on. So we have counts for all those. How long did that take? Well, let's do something first. Let's time how long that takes to run. So if I take that code and put it in a block, so a bracket before and after, and then send it the message time to run, let's print that, wait a few seconds. It will tell me it takes just under 5 seconds to run. Okay, so that's how long it takes to run that piece of code. If you want to load the profiling tools, go to System, Load Parcels, and type in AT, and go to AT Profiling UI and click OK. This is in italics here because I already have it loaded. But once that is loaded, I can send it the message, the same block, the message time profile. So let's do that. This will tell me where the time is being spent. And this is a really simplistic example. So our result, basically 100% of the time is spent in the code. And if we drill down, we can see 64% is spent, the majority of time is spent in select. And then a lot are spent in primitives, which is basically as quick as we can go. We can't really improve. But most of our time is being spent in the select, which we'd expect, because what we're doing here is for each unique word, we're going through all the words, all the almost 200,000 words, and saying, is each word equal to the word I'm looking for, and then getting the size. That's slow. So 754 times we're scanning almost 200,000 words. That's going to be slow, almost 5 seconds slow. So how can we improve that? Well, let's take a look. So we created associations, and we saw that was fairly slow. But a similar collection in Smalltalk is a bag. A bag basically keeps each unique item added to it and the count of how many items of that it has. So it's basically exactly what we are looking for here. And if I execute this code and inspect it, I can see I have each one of my words and how many times it occurred. And notice that was pretty fast, right? How fast was that to run? Let's check that out. That took 41 thousandths of a second, so 41 milliseconds, which is basically, if this was 4.1 seconds, it would be, this would be 100 times faster. So this is over 2 orders of magnitude faster to run this. And we can time profile it. It's really going to tell us pretty much nothing because it runs so quickly. We can see it puts it in the dictionary, but it's really, really fast, 0.06 seconds. So we can see where that is. So let's talk about a couple things about improving performance. Your biggest bang for the buck is always going to be architectural changes, where you change things to be done much more efficiently at an architectural level. Following that and similar are algorithmic changes. Largely what we've done here, we used bag, and rather than a brute force means of going through all the words, scanning for each unique word, going through all the 200,000 words every single time, looking for each match. We did it a much smarter way by creating a bag, and it was, again, 2 orders of magnitude faster. That's an algorithmic chain. Lastly, we have things, code tweaks, and that's your last line. Often you can do things that are faster. We had. Let me show you an example of a code tweak. Here, instead of saying ordered collection new, let me just do ordered collection new and inspect that. It creates an ordered collection whose size is basically 5. Now, as I add my 6th, it needs to create a new collection, double the size, copy each one over, and replace that. And if I'm doing hundreds of thousands of things, that's going to be fairly slow. I'm going to be creating a lot of new ordered collections and a lot of unnecessary copying. So if I know how many I'm going to do, I can say I can create it once, essentially, instead of doubling it. dozens and dozens of times, new colon 200,000 is going to be a code tweak that is much faster. So let's recap. We built a simple word counting example. We showed you how to time it by saying time to run to a block with the code. We showed you where to load the profiling tools by getting the parcel. The AT profiling UI will load it all. We showed you how to profile by sending the same block the message time profile. We took a look at the profiling results. It tells you the percent of time that's spent in a section of code. And we gave you some ideas. What we showed you improved code, which was essentially an improved collection, which used a better algorithm. So your biggest bang is architectural, then algorithmic, and then some code tweaks. We showed you an example of a code tweak. So again, if you're not familiar with this, I highly recommend you try loading and running this code maybe on some code that executes not as fast as you'd like or slower than you think it should. This is a staple tool, and it is really useful to find out where your time is going when things slow down. Again, any questions, comments, suggestions, send those to Art and Thomas, athomas@cincom.com. And until next time, have a great time with Cincom Smalltalk. Thank you.